Hello everyone. Now starts with our next lecture topic, that is the last topic from our unit number 1, midpoint circle drawing algorithm. In our last lecture we have seen the one type of circle generation algorithm called as a Bresenham circle generation algorithm. Now we will see the next type of circle drawing algorithm, that is midpoint. So these are the contents which we have covered up till now, and the last topic we are going to cover today, that is midpoint circle generation algorithm. So these are the two types. In this circle generation algorithm, it generates the same pixel position as like the Bresenham circle generation algorithm. We'll take the same example that we are solved with the Bresenhams. The same point will be generated by this midpoint circle generation algorithm. So the question on that will be like, explain a midpoint circle generating algorithm. So let's see with its introduction. So first of all, we will again find out which is the closest pixel to a current pixel, that we are going to find in this midpoint circle generation algorithm also. For each step we are finding out the closest pixel which is passing through a circle or which is passing nearby that curve. So this point we have to find. So for this again we are going to accept the center of a circle with its radius. So center we are showing with the xc and yc, and the radius is shown by r. So first we will see the center of that circle will be the origin. So we are assuming that the center of a circle will be the origin. So here you can see that 0, 0 is showing the center of a circle with its origin, right? Then next we are calculating the point that that is moved to proper position. So how we are going to find out that? Always we are adding something to this xc and yc. So corresponding x and the y value will be added to this xc comma yc, right? So here it is showing that x is a 0 and x is equal to y. Okay, so let's see how we are calculating the equation of a circle. We all of you know that the equation is x square plus y square minus r square. This is by using the Pythagoras theorem. We have seen before this lecture that x square plus y square minus r square is nothing but the equation of a circle. How we get that equation? By using this x minus xc square plus y minus yc square is equal to I square r square. But here xc and yc are 0, 0, as we are saying that it is starting from a center origin, that is 0, 0. So that's why it will becomes x square plus y square is equal to r square, but actual the equation is like this, right? Then we are saying that if any point is lying on that circumference of the circle, then it should satisfy the equation of that circle. So if I am saying a point is x comma y, you can see here this is what the point x comma y, which is on the boundary of a circle. This dotted curve is showing the boundary of a circle, right, which is with the this point is with radius r. You can see from here the radius is given as a r, right, and then it should satisfy the equation of a circle, right? How it is going to satisfy? We are putting that in the form of x square plus y square minus r square, right? So if point is inside the circle, then circle function will be negative, means the value of this function f circle will be negative if that point is inside the circle. If that point is outside, then the circle function giving a value as a positive, and if it is 0 means point is on the circle. The same thing we are going to apply, the same thing we have applied in this Bresenham's also. Now you can see if a circle function is giving a value which is less than 0, means a negative value, then that point is inside the boundary of a circle. Okay, then that point is inside the boundary of a circle. If it is 0, means that circle function is giving value 0, means what? That point x comma y is lying on the circumference of the circle, or it is on the circle boundary. And if that is greater than 0, then you can say that the point x comma y is outside of that circle. Means if the value is positive greater than 0, then point is outside. If it is negative, means less than 0, then point is inside. If it is 0, then you can say that a point is lying on the circumference of the circle. So this thing we are going to see, which is we already seen in this in that midpoint in Bresenham circle drawing algorithm. So in this again we are going to apply one decision parameter. Same decision parameter we have taken for the Bresenham's line generation algorithm. We have taken a decision parameter as a s. Then again in this circle generation, that is Bresenham's circle generation, we have taken one decision parameter P. Again we are going to take one decision parameter in this midpoint circle generation algorithm. What is the purpose of this decision parameter? This decide which point we have to select. Either we have to select A or we have to select B. Depending upon the value of decision parameter, we are going to choose a particular point. So here I am assuming that we have just plotted an xk comma yk. Which is the point xk comma yk? This is what the one point on the circle. We have plotted that point xk and yk, right? After that we have to check which are the next option we are having for this xk and yk. The next point we are having is this xk plus 1 and yk, and the next is having a, you can see this is what the first point, xk plus 1. What is the coordinate of this point? Xk plus 1 comma yk. Here y value is not changing, only x is incremented by 1. This may be closer to the curve, or you can have the another value, that is the next point, that is xk plus 1 comma yk minus 1. Means either from these 2 points you can select one, okay, but it may happen that curve is not passing through this point, okay. So what will be the equation for these 2 points? So decision parameter we are saying as a pk is our decision parameter. So if I am saying I will consider the first point, for the first point the parameter is xk plus 1 comma yk. If I am considering the second point, then parameter is xk plus 1 comma yk minus 1. So in this way we are having a 2 equation of a points for the finding out the point which is a next point on the circle. So by considering these 2 points, what we can take, we can find out the middle point of these 2, okay. What is the middle point? So you can see that this line is showing the midpoint of these 2 points, okay. So we are finding the midpoint of this 2 point. So how we are finding? We will make the yk, we are having a 2 value, that is yk and yk minus 1. So what will be the value of midpoint? It will be yk minus 1 by 2, right. It is nothing but a half a distance from in between yk and yk minus 1. That half distance is yk minus 1 by 2. So now we will find out the equation of a circle by using these 2 coordinate, that is xk plus 1 and yk minus 1 by 2. You can see that xk plus 1 and xk plus 1 are common for both point, only there is a difference between yk and yk minus 1. So what we have done? We have found out the midpoint over here, and what is the coordinate of that midpoint? It will be xk plus 1 and yk minus 1 by 2, that is half of its distance, right. So by putting that into the equation x square plus y square minus r square, the equation will look like this. So this is what the equation of a circle for that midpoint. Then next thing, if now by finding the equation of a circle, you can see here the equation of a circle we are finding out in terms of pk. If that calculated pk is less than 0, if that calculated pk is less than 0, then you can say that the point is inside the circle. So what we have to plot? We have to consider the above point, that is xk plus 1 comma yk. This point we have to consider. Now you can see that we are just calculating the midpoint, but considering the point which we want to or which is closer to that midpoint, okay. So this point is closer, so we are plotting the pixel, that is xk plus 1 comma yk when our pk value is less than 0. So in that case we are considering this point. You can see that if our pk value is less than 0, then we are selecting the upper point, okay. So in this selection of upper point, what is incremented? Only x is incremented, because this is my first previous point. Here only x is incremented, y is remaining same. So I am not increasing or decreasing y, right. So what after the selection of this point, if I am selected this as my next point, then again I have to select the next point. So what will be the next point? The next point will be this. So before the next point, if I have selected this as my first point, so what will be the next point? The next point is shown as a pk plus new. Pk new will be the my next point. Again for pk new, what will be the coordinate? Xk plus 2 comma yk minus 1 by 2, right? Minus 1 by 2 for this dash. Dash is shown as a midpoint, right? For this midpoint it will be yk minus 1 by 2. So this is what the equation of a circle if I am considering this as my first point. Okay, so this will be a new value of decision parameter. So we will solve this equation, that is xk plus 2 bracket square plus yk minus 1 by 2 bracket square minus r square. After solution of this we will get pk is equal to pk plus 2 xk plus 1. So how we are going to find out this? So this is pk new. So we'll make the subtraction of this pk new minus pk. After the subtraction of pk new minus pk, we are getting this pk plus 2 xk plus 1. This is same as a Bresenham's. In Bresenham's we have did this and I have given the explanation of all this how it comes. So subtraction method is given in that Bresenham, so you can follow that method also to this to do this subtraction. So after subtracting that pk from this pk new, we are getting the pk new is equal to pk plus 2 xk plus 1. So here there is no change in a row, only change in a column, means x is incremented by 1 but there is no change in the y value. Okay, this is if pk is less than 0. Now if that pk is greater than 0, so which point I am going to select? I will select this below point. Okay, that is yk minus 1. So what is the coordinates of that point? This is yk minus xk plus 1 comma yk minus 1 is the point. Now what will be the next point after the selection of this? The next point will be this, that is xk plus 2 comma yk minus 1 or xk plus 2 comma yk minus 2. These are the both points. Again you have to solve which point you have to take for the next curve generation. So again we are finding the midpoint over here, so you can see again this midpoint is found out. So how we are going to find out? So you can see the equation over here, it is pk new is equal to f circle. Now coordinate of this midpoint is xk plus 2 comma yk minus 3 by 2. Why 3 by 2? This is what the 1 by 2 plus 1. This is the distance between the two midpoint. The distance between two midpoint is 1 now. And what is the coordinate of this? It is 1 by 2. So 1 by 2 plus 1 is nothing but 3 by 2. So that's why it is yk minus 3 by 2. Not exactly the 3, not exactly the 2, not exactly the 1. That's why it is in between 1 and 2, that is 3 by 2. Okay. So this is what the xk plus 2 bracket square plus yk minus 3 by 2 bracket square minus r square. So then you have to solve this pk new, then subtract pk from this pk new. Pk we have find it out before that. So you have to subtract that pk from this pk new, and after subtraction you can get that pk new is equal to pk plus 2 xk minus 2 yk plus 1. Okay. So here you can take 2 common, 2 xk minus yk you can also take. Now you can see here whenever I am selecting this as my point, then here x value is also changed and y value is also changed. X is incremented by 1 and the y is decremented by 1. So here change in row also and the change in column also. So in this way we are finding our pk new. New means after this point these are the two different points. So how we are going to find out the next new point? So depending upon this equation pk new, right? So similarly we have to find out the first decision parameter over here, right? So that decision parameter we have to find out, that in this way we are going to find out. Initially we are saying that our x0 y0 is 0 comma r. With this value 0 comma r we are finding our initial decision parameter, that is nothing but this is what the first midpoint. You can see here this is what my first midpoint, right? So the equation of this first midpoint will be xa plus 1 comma yk minus 1 by 2, right? So I will put here xk we are having as a 0 is my xk, y is what? R, that is radius. So what will be the xk plus 1? 0 plus 1, that is 1. Yk minus 2 means r minus 1 by 2. So I will put this 1 and r minus 1 by 2 in the equation of circle, and it will becomes 1 square plus r minus 1 by 2 bracket square minus r square, and after solving that we are getting as a 5 divided by 4 minus r. right? But we, all of you know that we have to work with an integer, so that's why 5 divided by 4 will be 1 point something. So we are considering as an rounding value of this 1 point something as a 1, therefore the equation will be 1 minus r. So what is the initial value of decision parameter p0 is 1 minus r. Then depending upon this initial value we are going to find out the pk new, okay, new value of that parameter. So now you can see the in short step of this midpoint. So up till now we have seen how the equations are derived. Now directly we will see where to use that derived equation in the steps of circle generation algorithm. So first of all you have to choose a radius, right, and the center of a circle, and you have to plot that. So it will be shown as a x0 y0 and it will be 0 comma r. The first point x is 0 and y is nothing but the radius. So in this way I am plotting 0 comma r is nothing but the radius, right. The next thing you have to calculate the initial value of decision parameter. Lastly we have seen what is the decision parameter having the initial value, that is p is equal to 1 minus r, right, 1 minus r. Actually it is 5 by 4, but we are rounding off that 1 point something as a 1 minus r. So initial value is 1 minus r. Then you have to use the octant symmetry property, and you should use you can plot the first pixel, right, 0 comma r, and you can, by using the octant symmetry property, you can reflect that, okay. So after reflection of that you are having a two kind of value here, p0, right, you get the p value 1 minus r. So if that p is less than 0 or it is greater than 0, that you have to find out. If it is less than 0, then what we have to do, then we have to update our pk as pk plus 2x plus 1, okay. If your pk is less than 0 means your point is inside, in that case what you are going to do, pk is equal to pk plus 2x plus 1, okay, and you just increment by x by 1, means you are not decrementing y. So which pixel you are selecting, the next pixel you are selecting, right. Else what you are doing, you are just modifying pk is equal to pk plus 2 into x minus y plus 1, and in that case you are incrementing x by 1 and you are decrementing y by 1. So in that case which pixel you are selecting, this pixels means a down pixel, not a up pixel, down pixel. Whenever x and y both changes means you are selecting a down pixel. If only x changes means you are selecting up pixel, right, upper pixel. So here if pk is less than 0, then you are just incrementing x by 1 and you are updating this equation like this. Else you are incrementing x by 1, decrementing y by 1, and you are selecting here, that is pk is equal to 2x minus y, okay. So the next point is you have to update each and every pixel by using the octant symmetry property. So you can replicate that pixel. In this way you have to make the replication of that pixel, and then you are always moving that x is equal to x plus something, that is xc, and y is equal to y plus c. But here actually the center point may be anything, so we have to add that center coordinate to the midpoint x and y to plot the next point. How? You can see here the example that we have to plot a circle. It should be not a midpoint, not a Bresenham's, okay. So we have to plot the circle by midpoint algorithm whose radius is 3 and center is 0 comma 0. So here radius is 3. Same example we have taken like a Bresenham's algorithm. Same examples we are taking over here to see whether the same points we are plotting or not, okay. So the first point will be 0 comma r, okay. It is 0 comma 3 because r is equal to 3 here. So the first point will be 0 comma 3 and I am plotting that point like this, 0 comma 3. Then we have to replicate this 0 comma 3 by using that octant symmetry property. So in this way I am replicating all the points, okay. The next thing we have to calculate our decision parameter. So what is the initial value of decision parameter? It is 1 minus r. So 1 minus 3, it will becomes minus 2. Now I will check what is the value of p. So p is equal to minus 2 means our p is less than 0, and if p is less than 0, what we are taking, we are just incrementing x by 1. So x is incremented as x is equal to x plus 1, that is 1, 0 plus 1 is equal to 1, and we keep the y as it is. Y is nothing but y is equal to r is equal to 3. So y is same as a 3, only x is incremented by 1, and we have to take p is equal to p plus 2x plus 1. So what is the value of p? P is minus 2 plus 2 into, what is the value of x here? X is 1 plus 1. So p is now 1, right? So we are plotting the point 1 and 3, that will be my next point, 1 comma 3. Now again I will check whether my p is less than or greater than 0. So p is 1, so p is greater than 0. So whenever p is greater than 0, we are incrementing x by 1 and we are decrementing y by 1. So you can see here x is incremented by 1 and y is decremented by 1. So value of x and y are now 2 comma 2, and then we are updating the equation of p as a p is equal to p plus 2 into x minus y plus 1. So after putting the value of x and y, that is 2 minus 2, we get 2 as a value of p. Then which will be our next point? 2 comma 2 is our next point. So this is what 2 comma 2. Then next again we have to check whether our p is greater than 0. So what we get the value of p in previous equation? The value of p is 2. So in that case we will check again p is greater than 0. Yes. Again x is incremented by 1 and y is decremented by 1. So it is 3 and 1, and the again p is updated as a p plus 2 into x minus y plus 1, right? So that is 3 minus 1 is nothing but 2 plus 2 into 2 plus 1, that is 7. Okay. Now you can plot a new point, that is 3 comma 1. So the new point is plotted 3 comma 1. Okay. So this is what a step we are having. Now here x is greater than y, you can say x is greater than y, so we have to stop over here. Then we should replicate all these points. So first point is 0 comma 3, this point we have replicated in all the octants. Same way the next point is 1 comma 3, this we have to replicate in all the octants. Then next point is 2 comma 2, this we have to replicate in all octants. Then next is 3 comma 1, that we have to replicate in all the octants. So in this way we can find out the circle, or we can draw the circle by using the midpoint circle generation algorithm. So you can see that the same example we have taken in the Bresenham circle generation. Same points we are getting, that 0 comma 3, 1 comma 3, 2 comma 2 and 3 comma 1. By using this midpoint we are getting the same point, same circle is drawn, only we are finding the midpoint, and depending upon the value of that midpoint we are choosing whether it is upper pixel or lower pixel, right? So this is what the algorithm, that is midpoint circle generation algorithm. So here we are finishing with our unit number 1. So today we will stop over here, and from the next lecture we will start with our next unit from our computer graphics. So we will stop today here. Thank you all of you.